Today's lesson is on factors. First thing we need to do is find the prime factorization of each integer. How am I going to do that? Well, let's start by making a factor tree. And what are factors of 63? 3 and 21. 3 is prime, so I don't have to branch off from 3. 21, 3 and 7. So how am I going to write the prime factorization? I'm going to write every number that's at the end of our tree. So 3 times 3 times 7. Now I need the tree 81. 99. And there's multiple ways that we can do each one of these trees. But ultimately my prime factorization will be the same for every one. We all will get 3 times 3 times 3 times 3, no matter how we got to that. Now, look at negative 210. Now, first thing, what do you notice? The first thing is we have a negative number. So the first thing, let's factor out that negative number by factoring out negative 1. Now we'll do 210, 2 and 105, 5 and 25, 5 and 5. So we have, when I write my prime factorization, I want to write the numbers from smallest to biggest. And if I want to check, I can always take these numbers and multiply them. 3 times 3 times 7. Does it equal 63? If it does, I'm correct. If it doesn't, then I've done something incorrect. 3 times 3 times 3 times 3, does it equal 81? Negative 1 times 2 times 5 times 5 times 5, does it equal negative 210? Now, let's find the GCF for 2 terms. So the first thing I need to do is I need to factor and get my prime factorization for 48 and 64. 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Notice all these numbers at the end of the tree are prime. I'm going to now take and multiply to see if I've done this correctly. 2 times 2 times 2 times 2 times 3. Is it 48? Here it is. Now I'm going to tree 64. 2 times 32. 2 times 16. 4 times 4. 2 times 2. 2 times 2. So here I have 1, 2, 3, 4, 5, 6 2's. Now I'm going to write it, and I'm going to write all the 2's underneath each other. And I'm not going to put the 2 underneath the 3. So how do I find the GCF? I've got them circled and lined up. I just circle them. Now, just look at the top line. I have 2 times 2 times 2 times 2. Multiply 2 times 2 times 2 times 2. I get 16, so the GCF of 48 and 64 is 16. Now let's go do 28 and 75. We need to make our trees first. 28 is 2 times 2 times 7. 75. 5 times 15. 3 times 5. So I have 3. So I need to leave some space here. 2 times 2 times 7. And now I have 3, 5, and 5. So I have 28 and 75. Does anything look the same in both rows? No. So do I have a GCF? No GCF, or none. They have nothing, these 2 numbers have no factor in common. Now let's notice that number 3 is a little different than the first 2. How is that? Well, we have some variables in there. Well, how are we going to treat that? First thing is, let's let's tree the numbers. Calculate the variables aren't even there. Notice I already did 28, so I really didn't need to do it if I would have remembered that I'd already done it. 2 times 3 times 3. I had 2 2s and a 7. Now, how am I going to do a squared? A squared is just what? All it is 2 a's. Get some more room here. So I'm going to do AA. And I have b squared, which is bb. Notice I'm leaving some space so that I can write extras if I need it, and I don't put an a below a b. Now we need to circle things that are in common with both rows. Everything's in common, so now let's look at the top row and let's multiply it together. I had a 2, I had AA, what's A times A? A squared. Then I had B times B, which is B squared. So my GCF, what is in common with these two? And it's the greatest. 2 times A squared times B squared. Factoring. What is factoring? Before factoring trinomials, always check for the GCF first. So the first thing I want to do is look for the GCF every time. If there's a GCF, factor it out with the distributive property, then proceed with factoring the trinomial. So let's look at these. Okay, let's look at these 3 problems. So first thing we got to do is find the GCF, then we factor it out. So I need to tree 6. 2 times 3, I need to tree 15. 3 times 5. So now I write my prime factorization. A cubed is AAA. 15A, 3 and 5A. Now, what's the GCF? How do I find it? Circle what's in common with both rows. So my GCF is 3A. Where does the GCF go? It goes outside the parentheses, 3A. Let's bring my plus sign in. What was left from 6A cubed, or the first line here, after I took a 3A out? Well, if you notice, that's going to be what's left that was not circled. So that would be 2 times AA, which is 2A squared. What's left in the second row, or what's left of 15A after I take a 3A out? 5. Can we check this? Yes, we can either distribute it, like we learned in the previous lesson, or I can put the problem in Y1 and my answer in Y2 and check to see if they are the same. Look at number 9. First thing I'm going to do is find my GCF. So I need to tree 12, tree 16, now write my prime factorization for each one. 2, 2, 3. And I have 5 A's this time. And 2 B's. Now I have 1, 2, 3, 4 2's here. So 2, 2, 2, 2. Now I have 4 A's and 1 B. Find the GCF by circling what's in common with both rows. So we have 2 times 2, which is 4. 4 A's, A, that's A to the 4th, and 1 B. Where does my GCF go? outside my parentheses, so I have 4a to the 4b. Bring my plus down. What's left in the first row, once I take my GCF out? 3ab. What's left in the second row after I take the GCF out? Just 2 times 2, which is 4. Can I check this? Yes. How do I do that? Problem in Y1, answer in Y2. Now, let's look at problem 10. How is 10 different than 8 and 9? Well, it has 3 terms instead of 2. Do we do that any differently? No, we don't. Still going to make my factor tree and my prime factorization. Notice 2 is prime. So it's just going to be 2 and then 5 x's. 3 is prime. That's 3, and I have 4 x's. And 4 is not prime. I'm going to make it 3. 2 times 2. And I'm going to put the 2 underneath 3. And have 2 x's. Now with this one, I have to be careful. I have a 2 that's in the first row and the third row, which means there's a 2 in common in the first term and the last term, but there's no 2 in the middle term. So, it has to be in all 3 rows for it to be the GCF. Okay? So I have x times x, which is x squared. That's my GCF, goes outside. Bring the plus down, bring the minus down. What's left in the first row after I take out the GCF? 2x cubed. What's left in the second row? 3xx, which is 3x squared. So that goes in my second term. Third term, 2 times 2, which is 4. Check my answer. Problem in Y1, answer in Y2. Alright, in closure, see if you can find the pattern or sum and difference. Actually, the only thing that's new here is the third one and the fourth one. Should have done the first 2 closures. See if you can do them again. They should have been in the last lesson. Alright, let's look at these 2 problems, and we're going to group. We're going to factor by grouping here. So we want to group 2 terms together and factor out the GCF in each. So how would I do that? Well, I'm going to take the first 2 and group them together. And I'm going to group the second 2, and I'm going to put that plus sign goes with the 4, and I'm going to put a plus in the middle. So now I'm going to find GCF of those 2 terms. How am I going to do that? Well, let's make our prime factorization again. 3 is prime, so 3x, x, x. And the second one, 3 and 2x. What's in common in both? My GCF is 3x squared. Okay, that goes where? Outside, 3x squared. Let's bring the minus over. What's left out of the first row? X. What's left in the second row? Nothing. So we don't put a 0, we put a 1. We can check that 3x times x is 3x squared times x is 3x cubed. 3x squared times 1 is 3x squared. Now we need to do what's 4x, so 2 times 2x. 4 is 2 times 2. What's in common? 2 and a 2, so we multiply the GCF here is 4. that's positive 4, so we're going to put plus 4. What's left in the first one? X. We're going to bring the minus sign over. And what's left on line 2? Nothing, so remember we put a 1. Now notice, what's inside is the exact same. When we're factoring this, the inside goes first, x minus 1. Now, if the inside goes first, what's outside is going to go in the second. So we have 3x squared plus 4. Can we check this? Yes, we can. Problem in y1, answer in y2. Alright, let's look at the second. We're going to group the same. First 2, last 2. That minus is going inside with the 9, and we're going to put a plus in the middle. 4, treat that, 2 and 2, 3x, 8. 2 times 2 times 2 is 8, x squared. If you don't know that, do your factor tree. What's in common? 2, 2, x, x. GCF, 4. 4x squared. Where does it go? Outside. Bring down the plus. What's left in the first line? X. What's left in the second line? 2. Now we're going to do negative 9. There's 9, which is 3 times 3, x, 18. 3, 18, 2, 9. 3, 3. So we got a 2, 3, 3. What's in common? 3, 3. So our GCL is 3 times 3, which is 9. Where does it go? Outside. Now, since we have a negative 9, we need to factor a negative out of both terms. So we're factoring out a negative 9. When I do that, the second operation there changes from negative to positive. What's left in the first term? X. What's left in the second row? 2. Notice, what about your insides? They are the same. The inside match goes in first parenthesis. If the insides do not match, then you've either done something wrong or it cannot be factored. Alright, what's in the outside? 4x squared minus 9. Now, can we check that? Yes, we can. Problem in y1, answer in y2, do the tables match? I would like for you to try these 2 problems on your own. Closure. How would you factor these polynomial expressions by grouping method? Tell me how you're going to work these 2 problems.